In this problem, a wooden block of 1.25 kilograms rests on a table over a large hole, as seen in the figure. A 5 kilogram bullet with an initial velocity of VI is fired upwards to the bottom of the block and remains in the block after the collision. The block and the bullet rise to a maximum height of 21 centimeters. Describe how you would find the initial velocity of the bullet. So we want to know what this initial velocity is. And the only piece of information we really have, besides the masses of the two objects, is this maximum height. We also know that after the collision, the two objects have stuck together. So before the collision, this is what the scenario looks like. We've got the bullet moving and the blocks at rest. After the collision, the bullet is in the block and it's at a height of 22 centimeters above the table. So what we can use to find the initial velocity of the bullet is, eventually we're going to use momentum conservation, but at first we can find what the speed of the bullet and the block are right after the collision. So right after the collision has taken place, at what speed are those two moving? So first, find the velocity of the bullet and block together right after the collision. We can solve this using energy conservation. There's actually a couple of ways we can solve this, but one way is that we use energy conservation. Initially, it had 1/2 mv squared. We're going to say initially, this is initial, its height was at 0. So it has no gravitational potential energy at this point. This height is 0 initially, so it cancels out this entire term. At its highest point, its speed is 0. So we have no speed. But we do have gravitational potential energy, and that's going to be our 21 centimeters. So we can use energy conservation to find what the speed of both the bullet and the block are together. After we know that, then it turns into a momentum problem. So we can use momentum conservation. Anytime there's a collision, we want to use momentum conservation to determine what the speed of the bullet was before the collision. See if you can make the connection between this and what we did with our mystery with Mr. Goblin. Okay, so let's go ahead and try to calculate these. Part B, calculate the initial velocity. So you can see here, this is what we're going to use to find the initial velocity of the bullet and block at this location. So we have 1/2 mv squared mgh. Our masses cancel. 1/2 v squared is equal to 9.8 times 22 centimeters. G is in terms of meters, so we've got to convert this into meters as well. So 22 centimeters divided by 100. To get V all by itself, first I'm going to multiply this by 2. And then I'm going to take the square root. And I take the square root of both sides. Put it in your calculator and you find 2.1 meters per second. Alright. So let's go back. What did we just find? We just found what the initial speed of the bullet and the block were together. Remember, we said they had the same mass here as they did here. Okay, so now we've got to look at this as a momentum conservation. So let's try to draw the scenario. Before, we had this bullet moving and this block at rest. After, both of them are moving together at 2.1 meters per second. That's what we found over here. That's right after the collision. It still has no gravitational potential energy. It's just starting to gain it. So, momentum conservation. What are our masses here? We've got 1.25 and 5. So I can make this 1.25 and this 5. So let's take our bullet speed to be V1. 5 kilograms times some initial velocity, that's what we're trying to find. The block is at rest initially. Afterwards, both the block and the bullet are moving at this speed of 2.1 meters per second. So now, to get VI by itself, we want to divide both sides by 5. And what do we find? We find that the velocity is 2.6 meters per second. So that's our final answer. Let's look back at what we did here. First, we used energy conservation. We knew the maximum height. Maximum height, if we know the maximum height, energy conservation is usually pretty good to use. You may have solved this problem, or there's another way to solve this problem using the kinematic equations. As soon as these two are together, the bullet and the block, the only force acting on them, as soon as they're together, the only force acting on them is the force of gravity, down. So that's a constant acceleration. If you have a constant acceleration, you can use the kinematic equations. It is possible to solve the problem this way. But what we did was we used energy conservation because its final speed was 0. Its initial height was 0. And then after energy conservation, we used momentum conservation because there was the collision that occurred. And some of that energy, because it was an inelastic collision, some of that energy was lost due to sound and heat. And then we solve for the initial velocity of the bullet.